Nice to meet you. I'm Khatar Choktai and you're watching my YouTube channel, School of Advanced Chemistry. I'm going to solve some few typical MCQs regarding stoichiometry and mole ratio for AS chemistry student from past papers. Let's get started. Question number one, question number 9. 0.2 mole of hydrocarbon undergo complete combustion to give 17.6 gram of CO2 and 10.8 gram of water as the only products. What is the molecular formula of the hydrocarbon? So whenever you are supposed to find the formula of hydrocarbon, whenever they are asking to find the formula of hydrocarbon by this combustion route, then at that time you will have to write a general combustion equation. That is this one. CXHY plus X plus Y over 4O2 goes to X mole of CO2 and Y by 2 mole of H2O. So the first thing is you will write this general equation, general combustion equation for hydrocarbons. The second thing is whenever they are asking to make the formula of hydrocarbon, then you will balance this equation with respect to 1 mole of this hydrocarbon and you will find the answer of X and Y. So you know 0.2 mole of hydrocarbon is given mole is equal to 0.2 mole and at that time 17.64 grams CO2 carbon dioxide is supposed to be formed. So I can convert this mass of CO2 into moles. Mole is equal to mass over mr or AR. The mass is equal to 17.6, that is the given mass, divided by CO2 mr is equal to 44. So what is the answer of this mole? 17.6 divided by 44 and the answer is 205, 0.4 mole. So the mole of CO2, moles of CO2 is equal to 0.4. I mean, we have calculated the answer of X, that is 0.4 at the moment. The mass of water is also given, so we can find the moles of water from this data. So 10.8 mass of the water divided by mr of water, that is 18, divided by 18. So 10.8 divided by 18 and the answer is 0.6. So the moles of water, that is this one according to this equation, mole of water is equal to Y by 2 and its answer is 0.6 moles. Now we can find the value of X and Y simply using these equations, and then we will balance this equation by dividing 0.2 on all these numbers because we need to take 1 over here. If they are asking to make the formula of any hydrocarbon, then you will have to balance this equation in such a way that there is 1 mole of hydrocarbon. So the answer is 0.4, here's the answer is 0.6, here is the answer 0.2. So I am going to divide 0.2 over here, same is the case, divided by 0.2, same is the case, divided by 0.2 and so on. So that is equal to 1. 1 mole of hydrocarbon is going to give 2 mole of CO2 and 3 mole of HY over 2 H2O or 3 mole of H2O. So we have calculated that X is equal to 2 and we know Y over 2 is equal to 3, and what about Y? Y is equal to 3 into 2, that is equal to 6. So X is equal to 2, Y is equal to 6, C2H6 is the correct option of this hydrocarbon. Now come towards the next question. In this question, once again, the similar question. A mixture of 10 centimeter cube of methane and 10 centimeter cube of ethane was sparked with excess of oxygen. After cooling to the room temperature, the residual gas was passed through the aqueous potassium hydroxide. What volume of the gas was absorbed by the alkali? Combustion reaction, once again, methane plus ethane, and here the nominees are given. So 10 centimeter cube of methane CH4 plus 10 centimeter cube of ethane, the formula is C2H6. They are supposed to combust completely to give CO2 and H2O. So how many mole of carbon atoms are there? Let's suppose these are the moles. Volume can be supposed as mole, or mole can be supposed as a volume. So 10 carbon over here, 20 carbon over here. So overall 30, 20 plus 10, total 30 carbons are over here. So overall 30 mole or 30 centimeter cube of CO2 will be formed. And same is the case if we are supposed to find the answer of water, then 4 tens are 40 plus 6 tens are 60. 40 plus 60, that is equal to 100. 100 divided by 2, 100 by 2 mole of or volume of H2O gas, I mean steam, will be formed. At the moment, we are just concerned with the gas, residual gas that is going to react with alkali, that is being absorbed by the alkali. That is only one gas, that is this one, CO2. It is an acidic gas and it will react with potassium hydroxide. So 30 centimeter cube, because I'm taking 10 centimeter cube over here, centimeter cube, I have started with the centimeter cube. I suppose that the centimeter cube instead of moles, and I mean this answer is also said to be centimeter cube. So 30 centimeter cube of the CO2 will be formed and it all will be absorbed by potassium hydroxide because it's an acidic gas. So C is the correct option. I mean only CO2 will be absorbed and the amount of CO2 formed is 30 centimeter cube. The next question is 0 point, no, it's a repeated question. The next question is this one. A garden fertilizer is said to have phosphorus contents of 30% P2O5 soluble in water. What is the percentage by mass of phosphorus in fertilizer? The first thing is this fertilizer that is having P2O5, I mean phosphorus content, it is 30%, just 30% pure. So whenever you are having just a formula and you are supposed to find the answer of percentage by mass, then you can start from its MR. You can start from its MR. So what is the MR of this P2O5? Let's suppose this is 100% pure sample of P2O5. Its MR is equal to 2 into 31 plus 5 into 16. 2 into 31 plus 5 into 16, and the answer is 142. So 142 gram. Let's suppose if this fertilizer is 100% pure, this sample, and I'm taking 142 gram of this phosphorus fertilizer from a shopkeeper. If I'm buying 142 gram of this sample from a shopkeeper, then how much phosphorus will be there? That is 2 into 31, I mean 62. So 142 gram will give maximum 62 gram of phosphorus. P2O5 versus phosphorus. And if I'm using, let's suppose 100 gram, if I'm taking 100 gram, then how much phosphorus will be there? That will be 62 over 142 into 100. So 62 divided by 142 multiplied by 100. And the answer is 1343.66. 43.66. So if I'm taking 100 gram this phosphorus fertilizer and it is 100% pure, then the maximum phosphorus that can be get from here is equal to this one. But you know, this phosphorus sample is 30% pure. So actually what will be the amount of phosphorus? That will be 30% of this amount. I mean 43.66 multiplied by 30%, 30 over 100, and this answer will be equal to 13. So B is the correct option. 13% phosphorus will be there if the sample is 30% pure. Now come toward the next question. The next question is, let me raise it first, this one. Exactly 1 gram of metallic element react completely with 300 centimeter cube of oxygen at 298 Kelvin and 1 atm pressure to form an oxide which contains O2 negative ions. The volume of 1 mole of gas at this temperature and pressure is equal to 24 dm cube. What could be the identity of metal, calcium, magnesium, potassium, sodium? I mean, either there are two metal from group 2 elements and these two one and these two are group 1 element. So the basic thing is we are going to react 1 gram of each metallic element that is going to react with oxygen, and the volume of oxygen is equal to 300 centimeter cube. What is the use of this volume of centimeter cube of gas? It can be changed into moles because it's given volume of 1 mole is equal to 24 dm cube, or it is also 24,000 centimeter cube. So 24,000 centimeter cube is equal to 1 mole, and if we are having just 300 centimeter cube, how much mole of oxygen will be there? O2 will be there. That will be 300 over 24,000 centimeter cube. Now, what is the answer in mole of oxygen? 300 divided by 24,000, and here is the answer. So the answer is 0.0125. 0.0125 mole of oxygen is being used in this experiment, and 1 gram of that metal is going to react with this oxygen. The next thing is the oxide that is being formed in this question, in this reaction, that is O2 negative ion. So calcium oxide that is also containing 2 minus oxide, I mean normal oxide. MgO is also normal oxide. It is also having oxygen 2 minus or minus 2. Same is the case K2O. It is also having oxygen that is 2 minus, and same is the case Na2O. It is also having oxygen that is 2 minus. So all these four possible samples are having same formula of oxide ion. Now the next thing is I'm going to use every element, I mean the mole of element one with respect to 1 gram, and then I will check which one element is going to meet with exactly 0.0125 mole of oxygen for the complete reaction. Now you know it's MR is equal to AR is equal to 40. So what will be the mole of calcium, for example? The mole of calcium will be 1 gram, 1 mass divided by 40 is the calcium, mole of calcium, and it is going to react with oxygen, you know, for the complete combustion, and it is going to make calcium oxide. 1 mole of calcium is equal to half mole of oxygen, right, for the balanced chemical equation, and 1 over 40 mole will be equal to 1 over 40 mole of calcium will demand oxygen, I mean by half, and it will be 1 over 80. So The answer is 0.0125. Yes. So if I'm using this 1 gram of calcium in this case, then the amount of oxygen will be exactly this one. Once again, first of all, you will balance this chemical, you will write this balanced chemical equation. You will balance it to make normal oxide. Calcium plus oxygen goes to CaO. Calcium 1 mole, 1 mole, 1 oxygen, so half mole of oxygen is being used. The next thing, let me check it once again. Yes, the same answer is over here. So answer A is the correct option. Calcium is the metal. If we are using 1 gram calcium, then it will use this mole of oxygen, or in other word, you can say it will use 300 centimeter cube oxygen. And this sample, 1 gram sample of other element, will either they will use more than 300 centimeter cube of oxygen, or they will use less than 300 centimeter cube of oxygen. So A is the correct option. Now the next thing is, next question over here, that is 0.144 gram of aluminium compound react with an excess water to make to produce a gas. This gas burned completely in oxygen to form H2O and 72 centimeter cube of CO2 only. So this time just CO2 is given, its volume is given, and conditions are RTP, room temperature and pressure. So again, what is the use of this volume of any gas at RTP? Mean we can change this volume into mole. So 24,000 centimeter cube, we know that of any gas at RTP is equal to 1 mole. At the moment we are having 72 centimeter cube CO2, then its mole will be equal to 72 divided by 24,000. And the answer is 72 divided by 24,000, and 0. That is equal to 3 into 10 raised to power minus 3 moles of CO2. And if you are going to combust a gas, any compound, and it's making CO2, so it means that all of its carbons, all carbon in this gas will change into CO2. On complete combustion of any compound, all carbon content will change themselves into CO2. Whole carbon has been converted into CO2. So the mole of CO2 will also be equal to the mole of carbon in that compound. So mole of carbon will be the same, 3 into 10 raised to power minus 3. And we can find the mass of carbon in this compound, mass of carbon. So I'm going to multiply it by its AR. So mole multiplied by its AR is equal to its mass, and the answer is 0.036 grams. So the total mass of compound is 0.144. This is the mass of carbon. So what will be the mass of aluminum? Aluminium versus carbon. This is the total mass of aluminum compound. This is the mass of carbon in this compound. What will be the remaining mass? And that is 0.144 minus 0.036, and the answer is 0.108. 0.108. Now I'm going to apply the step of empirical formula, and I'm dividing it by 27, it's AR, and dividing it by 12. So what will be the answer over here? Let's see. Its answer is equal to 0.004, and its answer is 0.003, and the simplest ratio will be 4:3. So aluminium is equal to 4, carbon is equal to 3, and C is the correct option. C is the correct option. Now come towards the next question. Use of data booklet is relevant to this question. Ferrochrome is an alloy of iron, chromium. Ferrochrome can be dissolved in dilute sulfuric acid to produce mixture of FeSO4, chromium sulfate. The FeSO4 react with K2Cr27 in acid solution according to the following equation. So in this equation, 14 mole of, H positive ion is going to react with 6 mole of Fe2 positive ion, that is going to react with 1 mole of Cr2O7 to gives 2 mole of chromium 3 positive, 6 mole of iron 3 and 7 mole of H2O. When 1 gram of ferrochrome is dissolved in dilute sulfuric acid and the resulting solution is titrated with 13 centimeter cube of 0.1 mole per dm cube K2Cr27 is required for the complete reaction. What is the percentage by mass of iron in the sample? You know, the total mass of the sample is equal to 1 gram. This is the total mass. I mean, the formula of percentage by mass is mean mass of this iron, that is to be calculated by the help of this equation, divided by total mass, and total mass is equal to 100 gram, multiply by 100, and we will get the final answer. So the basic thing is to find the mass of iron. So in this equation, what is the given? Given is the volume and centimeter cube of K2Cr27. So we can find the mole from this data. Whenever you are given a centimeter cube and the concentration of any substance, then you can change it into moles. I mean 13.1 multiplied by 0.1 divided by 1000, because this volume is in centimeter cube, and here will be the answer in mole. So how many mole of Cr2O7 is over here? 13.1 multiplied by 0.1 divided by 1000, and the answer is 1.3 into 10 to the power minus 3. 1.31 into 10 to the power minus 3. So these are the mole of K2Cr2O7, and same mole will be the Cr2O7 to negative ion. I mean K2Cr2O7 is having 1 mole of Cr2O7 negative ion. So this answer will definitely, obviously that is the same answer for the mole of Cr2O7. I mean the mole of K2Cr2O7 will be same the mole of Cr2O7. From this balanced chemical equation, we can see that 1 mole of Cr2O7 is going to react with 6 mole of iron 2 positive ion. So 1 mole is equal to 6 mole, and if we are using the mole of K2Cr2O7 is equal to this one, or Cr2O7 is equal to this one. So Cr2O7 versus Fe. I mean 1 mole, 6 mole, and 1.31 into 10 raised to power minus 3 is equal to 6 into 1.31 into 10 raised to power minus 3. So the final answer is over here, and that is 7.86. 7.86 into 10 raised to power minus 3. So generally speaking, we have calculated the mole of iron. Now we can change this mole into mass. I mean mole multiplied by its AR. AR is equal to 56. So this answer multiplied by roughly 56, and answer is over here 0.440. So 0.44 gram of iron is present. I mean, as you may get confused from this iron 2 positive ion, but just keep in your mind that the mass of iron 2 positive ion, mass of iron 3 positive ion, or the mass of simple iron, mass is same. The difference is basically of electrons. So any ion or a normal element, its element is having same AR. So now finally 0.44 divided by 1, that is the total mass of ferrochrome, multiplied by 100, and answer will be almost 44%. So that is the answer. D is the correct answer. Come towards the next question, that is empirical formula basically. So how to find the empirical formula of this one? User data booklet is relevant to this question. In lead petrol, there is an additive composed of lead, carbon, and hydrogen only. This compound contains 29.7% carbon, 6.19% hydrogen by mass. What is the value of X in the empirical formula? So in this case, you can see that the mole of Pb is equal to 1 and the mole of carbon atom is equal to 8. And if Pb is equal to 1, carbon is equal to 8, then what will be the value of its hydrogen? So simply two percentages are given. If you are going to apply the basic rule of empirical formula, then the percentage by mass of lead will be equal to, only three elements are there, it will be percentage of Pb will be equal to 100 minus 29.7 plus 6.19%. So what is the answer? Let me check its percentage. 100 and minus 29.7 plus 6.19, and that is equal to 64.11%. So 64.11% lead. The percentage of carbon is equal to 29.7%. The percentage of hydrogen is 6.19%. So what is the AR of Pb lead? You can see it over here. Here is a data booklet. The mass of Pb is equal to 207.2. So 207 divided by 207 divided by 12 divided by 1. AR of hydrogen is equal to 1. AR of carbon is equal to 12. So what will be the answer? Divided by 207, that is equal to 0 0.03, 0 0.3. So 0.3, and what will be its answer? 29.7 divided by 12, and the answer is 2.47, 2.475, and this is 6.19, the similar one. This is the smallest answer, so it is divided by, we will divide it to all other values or other numbers, 0 0.3, 0 0.3. So it will be equal to 1, and this divided by 0 0.3, that is equal to 8.25 almost, and this one 6.19 divided by 0 0.3, that is equal to 20 point something 6. So the main answers are over here. Here is a 1, 8 point something 20, and these are not significant. So 1 ratio 8, as you have seen here, is 8. So 1 Pb, 8 carbon, and at that time hydrogen will be equal to 20. So D is the correct option. That's all about this episode. Thank you very much. Please subscribe my channel, hit the bell icon, and share it with your friends. Thank you. Thank you very much. Have a nice day.